Hello everyone, welcome to Bodhi Academy. Let's start with the today's PYQ series. Subject Chemistry and chapter Alcohols, Phenols and Ethers. Okay, so let's begin with the first question. What is the question? Write chemical equations for the following. First, the reaction they asked is acetic acid reacts with phosphorus pentachloride. Yeah. So this is your acetic acid CH3COH. PCl5 is your phosphorus pentachloride, penta meaning 5 chlorine atoms. When it reacts, these three products you'll get. This is your acetyl chloride, CH3COCl. Okay, and POCl3 and HCl. Okay, these are your byproducts. This is your main product, acetyl chloride. How you write this acetyl chloride? Sometimes students don't understand. CH3COCl, CH3C double bond O and Cl. This group is called as your acetyl group. This is your acetyl group. This is phosphorus pentachloride. This is acetic acid. This is a common name of this molecule. Okay. Yes. So this is the reaction which was supposed to be solved. Okay, now let's start with the second question. What is the question? Again, there is a chemical equation. Decarboxylation of sodium salt of propanoic acid. Okay, so this is propanoic acid. There is this functional group. This is a functional group, acid functional group. So this is a propanoic acid. Why it is called propanoic acid? Because there are 3 carbons. Prop means 3 carbons. So propane means there are single bond in between the carbon atoms. So it is propane and oic acid. Okay, oic acid is for this suffix is for the acid functional group. So this is called as propanoic acid. So first let's prepare the sodium salt of propanoic acid, right? So this is a propanoic acid. When it reacts with the NaOH, that is your soda lime, NaOH plus CaO, calcium oxide, what you'll get is the sodium salt of propanoic acid. So this is the sodium salt of propanoic acid. Okay, iron, no, it is a iron minus Na plus and COO minus, sodium salt of propanoic acid. And then when this sodium salt of propanoic acid further reacts with the same NaOH and CaO, and you will get a hydrocarbon, that is ethane. A hydrocarbon is obtained. So there are 2 carbons. One carbon is reduced. Now what is happening? Decarboxylation, they said, right? Decarboxylation. So the carboxylate, this group C double bond O and O gets lost. Decarboxylation means removal of carbon dioxide. C double bond O means carbon dioxide, NaOH and ethane, and Na2CO3 sodium carbonate, it is your byproduct. So what is happening? Propanoic acid, soda lime and sodium salt of propanoic acid is obtained, and further you are reacting this sodium salt with again the NaOH and CaO, you will get the hydrocarbon, that is ethane, with the byproduct sodium carbonate. Okay, let's move with the third question. What is the question? Arrange the following compounds in decreasing order of acidity. What are the 3 compounds? Water, alcohol ROH and an ethyne molecule. Okay, C triple bond C. Okay, now how will identify which is more acidic, which is least acidic? Is from this sentence which is in quotation, that is more stable is the conjugate base, stronger is the acid. Now you have to find which, first you have to do the dissociation of all these molecules, water, alcohol and this ethyne molecule. Okay, now it will dissociate to give you H plus ion and OH minus ion. Now this OH minus is your conjugate base, this is your acids, H plus your acid, okay, and conjugate base. Now this conjugate base is more stable. So more stable is the conjugate base, stronger is the acid. This is more stable, and then next is this ROH dissociates into H plus and OR minus, which is your conjugate base. This is next after this, and last one is ethyne. Ethyne will dissociate into H plus and CH triple bond C minus. Okay, among these 3, this OH minus is the most stable conjugate base. So the acid of this water will be more acidic, highly acidic. Therefore, when you see the order, they have asked us the decreasing order. Okay, so this way it decreases. Water will be most acidic, and then alcohol, ROH, and then your ethyne molecule. So this way the acidity decreases and the stability of the conjugate base will increase this side. So this is how it is. Let's start with the next question. Phenol. What is the question? Phenol C6H5OH, when it first reacts with concentrated sulfuric acid, forms a product Y. Then the compound Y is reacted with concentrated nitric acid to form Z. Identify Y and Z. This is the question. Okay. The moment you read, you may not understand. So first, we should go step by step. Means what they have asked. Phenol is the structure. C6H5 is your phenyl ring, your benzene ring actually. Okay, and then OH group. This is your phenol. Okay. That when reacts with concentrated sulfuric acid. What type of reaction it is? Phenol when reacts with sulfuric acid, concentrated sulfuric acid, will give you these ortho and para products. Sulfonyl group, SO3H group get attached to the ortho and para position of the phenol. This reaction is called as electrophilic substitution reaction. Okay, electrophilic substitution reaction of phenol. In the presence of concentrated sulfuric acid, phenol gives electrophilic substitution reaction where ortho and mixture of ortho and para products have been obtained. Okay, they have asked you the product Y. There is only one product they have asked. Okay, we know that ortho and para product, para is your major product. Okay, so Y means your Y will be this. This is your major product. Okay, this is your major product. Okay, then further they said this product Y will react with concentrated nitric acid. In the presence of nitric acid, you will get this product, concentrated nitric acid. No? So what will happen? You get this product, that is tri-substituted phenol, 2,4,6 trinitrophenol. Okay, this is the IUPAC name of the molecule. A common name, you can pause the video and think what is the common name for this molecule. Okay, it is picric acid. So picric acid is your compound Z, and Y is your para product, para sulfonyl benzene. Okay, that's it. Okay, let's move with the next question. What is the question? Methoxybenzene reacts with ethanoyl chloride in the presence of anhydrous AlCl3. Okay, now this is the question. Methoxybenzene. Methoxybenzene is nothing but this structure, anisole. Okay, methoxy. This group is your methoxy group. OCH3 is your methoxy group, which is attached to the benzene ring. That's why it is called as methoxybenzene. Okay, and common name for this molecule is anisole. Okay, this when reacts with ethanoyl chloride you can also say it as ethyl chloride in the presence of anhydrous AlCl3. Anhydrous AlCl3 is your catalyst. Okay, in the presence of this catalyst, this molecule ethyl chloride is getting added. Okay, then products, what products you are going to get is again orthoethyl anisole and para-ethyl anisole. These are the two products you are going to get. Okay, para-ethyl anisole is your major product. Para-ethyl anisole is your major product and this is your minor product. So you will get a mixture of these two products, among which the para-ethyl anisole is your major product. Okay, what type of reaction it is? It is an electrophilic substitution reaction. Under electrophilic substitution reaction, here an alkyl group is getting added. So it is Friedel-Crafts alkylation reaction. It is a Friedel-Crafts alkylation reaction. In the question, they have not mentioned to write the name, but in case of any other question, they have asked you to mention the name of the reaction, then it is a electrophilic substitution reaction, which is a Friedel-Crafts alkylation. Let's start with the next question. What is the question? It is a give reason type question. They have asked, propanol has a higher boiling point than butane. Why propanol is having a higher boiling point than butane? That is the question. See, first we'll see what is the structure of propanol and what is the structure of butane. Okay, propanol and butane. Propanol means prop 3 carbons and OL. OL means an alcoholic functional group. So this is what is the structure. 3 carbons having a single bond in between them because it is propane. AN means single bond, and OL is for alcohol, so OH. This is the structure of propanol. Let's come to butane. Butane, it is a straight chain. Butane. But means 4 carbons. So 4 carbons. ANE means single bond. It's an alkane. Okay. See. This is the structure of butane. Next. Now the difference is a kind of, I have explained you in a simple way. You have to write in your exam, if this question comes, you have to write in frame sentences and write it. Okay. The same thing, you have to frame sentences and write it. Okay. Since it has a OH group, right? It has a OH group. So it is a polar molecule. Polarity means what? Separation of charges. Okay. This OH, no, it will have partial negative and partial positive charge. You know, no, oxygen. Okay, I'll come this side. Okay, oxygen, it is electronegative, right? Highly electronegative. So what will happen? This will have a partial negative charge. Okay, and this will have a positive charge. So means what? Separation of charges happening. This is a polar molecule. Polar molecule, and what it will show? This type of a molecule, it will show hydrogen bonding. That it will show strong intermolecular hydrogen bonding. Means it will bond with the other molecules. There will be a strong force of attraction between the two molecules of propanols. The two molecules of propanol. In a solution, there are many molecules, no, of propanol. So what it will show? It will show hydrogen bonding. Okay. Strong hydrogen, intermolecular hydrogen bonding. Intermolecular means hydrogen bonding taking place between the two different molecules. Okay. So if there is a strong intermolecular hydrogen bonding, breaking of that bond will require some more energy, right? So more energy means temperature. Now when you heat, what will happen? Energy, you are providing energy. So it will have a higher boiling point. Since it requires more energy, that is it will have higher boiling point. Okay. Then when it comes to butane, it has no OH group or no polar group present over here. It is just a hydrocarbon, which is having carbon and hydrogen atoms. So it is a non-polar molecule. It will not show any type of hydrogen bonding. But these molecules are being held together by a weak van der Waals force. Weak van der Waals forces. So the force of attraction will be less. So it will require very less energy to break. Okay. Hence it will have lower boiling point. So that's how the propanol will have, being a polar molecule, it will have strong intermolecular hydrogen bonding and it requires more energy, thus it will have higher boiling point. Whereas a butane, which is non-polar, which is just a hydrocarbon, which will require less energy, which are held together by weak van der Waals forces, thus can be broken easily and will have lower boiling point. So the same thing you have to frame in your own sentences and to mention the structures of both the molecules. Next question. Phenol is heated with the zinc dust. It is again a small reaction, but an important reaction. Okay, reaction of a phenol with the zinc dust. What it will give you? It will give you a benzene ring and ZNO. Benzene ring and ZNO. That's it. Okay. And this is a very simple reaction and mostly asked. These questions are asked. Yeah. For MCQs also they may ask you like this, meaning predict the product kind of, or direct question like this. Okay. Okay. Let's start with the next question. Now it is a MCQ kind of question. Okay. Phenol reacts with bromine in CS2 at low temperature to give which product? Options: metabromophenol, ortho and parabromophenol. Last option, 2,4,6 tribromophenol. Okay, you can pause the video and think what could be the answer. Okay, metabromophenol is ruled out. Okay, because we have never seen metabromophenol. Ortho and parabromophenol is most of the time formed. Okay, phenol when reacts with Br, this is the reaction. Phenol when reacts with Br in CS2, means bromine in CS2 at low temperature. This is the temperature. You get usually this a mixture of ortho and parabromophenol. Okay, major product is parabromophenol, but let's go according to the options. Here they have asked ortho and para is there in the option. Para is also there, but when we react, what products it will give is these two products. They didn't mention what is specifically, so the option will be ortho and parabromophenol. 2,4,6 tribromo is also there, which is again ruled out because that will be obtained if in some other reagent. If the reagent is different, overreaction is taking place. In that case, you will get multi-substituted product, tri-substituted product. Okay, here it is a controlled reaction. Low temperature is there. That means it is a controlled reaction. When controlled reaction takes place, we get our desired products. Okay, when it is higher temperature or if it is any strong reagent is been present, what will happen? Such kind of tribromo derivative is being obtained. Okay, in this case, your answer will be ortho and parabromophenol. Let's start with the next question. What is the question? Again, I give reason type question. Alcohols are more soluble in water than hydrocarbons of comparable molecular masses. Okay. Alcohols and what is it? Hydrocarbons. Okay. Alcohols, this is by example I have given, this is the structure of an alcohol. Ethanol, it is C2 carbons and OH. So example is an ethanol and this is a propane molecule, which is a hydrocarbon. Hydrocarbon means just hydrogen and carbon. This is an alcohol which is having OH group. Again, the reason is going to be the same due to hydrogen bonding. Okay, same due to the presence of a OH group. OH group is a polar, thus it will have a strong hydrogen bonding with the water molecule. This is the structure of water molecule, right? And this is an alcohol which is having a OH group where this hydrogen is forming it shows a hydrogen bonding with water molecule, and this is called as what again? The hydrogen bonding is between what? Two different molecules. See, intermolecular hydrogen bonding again. Okay. Okay. That is why, since it is forming a strong hydrogen bonding with the water, it is easily soluble, or you can say miscible. Water and alcohol both are liquids, right? So miscible in water. Okay. As a result, alcohols are more soluble or miscible, you can say, in water. Okay. Hydrocarbons. Hydrocarbons, we know there is no polar groups, so it is non-polar. There is no hydrogen bonding. So what will happen? Due to the absence of hydrogen bonding, the hydrocarbon remains insoluble. Okay. Okay. So that's how it is proved. Due to hydrogen bonding, alcohols are more soluble and hydrocarbons are not soluble because it is not having any kind of hydrogen bonding with the water molecule. So today's last question. What is the question? Write the reaction of ethanol with Fellings solution. Now this test, see, this is a Fellings test. Fellings solution, it is a mixture of copper solution, some mixture of some like copper sulfate and water. It is prepared in your labs, okay, which you will get directly, which is a mixture of two solutions. Copper ka two solutions are there. Okay? Mixture of that is your Fellings solution, which will have what? Your copper solution and aqueous NaOH. Okay. This when reacts with your ethanol means ALC, it is your aldehyde. Okay. Okay. When it reacts, you will get what is this? Acetic acid and Cu2O. Cu2O is your what? Precipitate, reddish brown precipitate. When you do this test in your labs, if you get the reddish brown precipitate, a red color precipitate, it confirms the presence of aldehydic functional group. So this test is specifically used for the detection of aldehydic functional group. Okay. Okay. So they will give you some unknown sample, right? So when you test that sample with this spelling solution, if you get this reddish brown precipitate, it indicates the presence of aldehydic functional group. So this is what is the reaction. Okay. Yes. That's it for today's classes. Thank you for watching today's video. Please like, subscribe and share to Buddhi Academy. Thank you.